Hi, I'm Haddo, and welcome to this module on another essential multimeter skill. As a professional automotive technician, this will become one of your favourite tools. We've already looked at some common automotive multimeters and their functions. Now I'm going to show you how to perform voltage, current and resistance measurements. If you have a multimeter, it may help if you have it with you as you watch this video. Right, let's start with measuring voltage, which is likely to be the most common test you'll perform. Like water pressure in a pipe, voltage is essentially electrical pressure. So a voltmeter is really an electrical pressure gauge. Voltage is also known as a potential difference. So this meter will measure the difference in pressure between these 2 points. If I put the black lead on absolute zero, or a ground, and the red lead on a pressure point of 12 volts, the difference is 12 volts. If I were to put this lead on a pressure point of 12 volts and this lead on a pressure point of 10 volts, the meter will read the difference being 2 volts. So, what do we need to do to make sure we take a correct voltage measurement? First, I need to put the leads into the correct jacks. The black lead goes into the COM or common jack port for any measurement you will perform. For voltage, the red lead goes into this red port, labelled like this. I need to select DC volts. Automotive multimeters default to DC, but always check that you're on the correct setting. If you do see this AC symbol, press the mode button until you have the DC symbol. Now we're ready to take some measurements. Voltmeters are connected in parallel, which means they're just added onto the circuit. Let's check the supply voltage of the battery. There, I have 12.5 volts. Now with the engine running, I'll check the battery again. I now have 14 volts. Notice that this positive battery lead is connected from here to the alternator output terminal. With my negative multimeter lead still connected to a good ground point, I'm now going to check the pressure at each end of the positive battery lead. At the alternator, I have 14.1 volts. And at the other end, I have 14 volts. So we have a difference in voltage at each end. Let's check the difference in voltage between these 2 points. I'll place my red lead here, as this would be the more positive terminal with the engine running. I'll place the other lead on the positive of the battery. I've lost or dropped 0.1 volts between the alternator and the battery. This is a voltage drop reading. Now let's move on to measuring current, which is the flow of electrons through a circuit and is measured in amps. In other words, using the water analogy again, current is like water flowing through a pipe. Typically, we can only measure up to 10 amps with a DMM. Some meters can measure up to 20 amps for a short period of time, but you're more likely to blow the fuse, and they can be expensive. Before we start, we must check the internal fuse is okay. I'm going to show you the best way to do this without pulling the meter apart. Place the red lead into the red jack marked volt ohm, which is normally on the right. Turn the meter to read ohms and then place the red tip into the amp jack like this. The meter should read 0. However, if you see this reading, the fuse is blown and it will need to be replaced. With the leads connected like this, select amps. You should now have this symbol. If not, press the mode button until you do. With the circuit turned off, break the circuit and connect the meter like this, with the red lead closest to the power supply. Be careful not to create any short circuits. You can see that the meter now forms part of the circuit. Turn the circuit on and take the reading. Here we have 0.88 amps. On a car, it can be a little harder to break into the circuit with connections like these. Breaking the circuit by removing a fuse is the best way if possible. Circuits with higher current, or those that can't easily be broken into, are best measured with an induction amp clamp like this. The advantages of this type of meter are: 1, you don't have to disconnect the circuit or the power source, and 2, there's no risk of short circuits and component damage. So let's measure the starter current draw. I'll select the correct function here. I'll need the highest setting for this task, and if required, zero the meter. Note, some meters have a polarity direction here. Place the clamp around the cable. It's best to place it diagonal so the cable touches the clamp like this. Remember, the circuit must be operating to get current to flow. Crank please. There, we had 185 amps. You can still measure through the fuse circuit with a clamp meter, but you'll need one of these extensions. Induction amp clamps certainly make life easier. They're quick and there's no risk of short circuits. Finally, let's talk about measuring resistance. The current flow of any electrical circuit is controlled by the resistance of the load. Any resistance outside of the load will have a negative effect on the circuit's operation. To measure resistance, we connect the leads in the same way as a voltage measurement. Select resistance, which is represented by the omega symbol. Now place the leads together without your fingers touching the tips, as you can get a false reading. We should have 0. If not, we have some resistance in the leads. Now, so we don't get a false reading, press the rel button, which is like a 0. Finally, I'll check the resistance of this high tension lead. This one is 0.747 k ohms. The K stands for 1000, so it's actually 747 ohms. And this one is open circuit. Here's some tips for you when measuring resistance. Never put an ohm meter in a powered circuit. Only give the meter one path to measure. And always check the symbol to see whether it's ohms, k ohms or mega ohms. Understanding how to use a multimeter correctly is such an important skill for today's technicians. I hope you've enjoyed this training module.